Hello, my name is Simon. In this tutorial, I will teach you how to install the particle tracking of orientation and velocity program. I will be assuming that you have already downloaded the program off Git. In my case, I've placed it in a folder on the desktop. I will be using Anaconda environments. However, a very similar process can be done using virtual environments. The first step is to create a virtual environment. To do this, we create one using conda create, and we name this environment PTOV. We'll be using Python 3.9, however newer versions are probably viable as well. Throughout this tutorial a lot of installation will happen naturally, and in these cases I may skip ahead in time. The next step is to install the required libraries for PTOV. To do this, we navigate the terminal to wherever we downloaded the program off Git. In my case, it's on desktop/PTOV. After entering, we can run the pip install -r to install the requirements.txt file. I then press enter to run this. This may take a while. Now that we've installed all the base packages, we need to install the PyTorch 3D library. In my experience, it's best to do this directly off their Git. So if we go to their website, seen here, and navigate to the install.md, then we'll notice there are many ways to do this, but what I recommend is to just install it directly off GitHub. So we will need to run this command, pip install, and then this URL. This command is also found in the README. We are now ready to install the PTOV library itself. So first I close this window. Then we need to pip install, and I use -e. This means it's editable, so pip automatically updates if we change things in the package. This is probably useful as this is a project in development. Then we need to provide the path to the library. Since I'm already located in the library, this will just be a dot. Then we press enter to run it. We've now successfully installed PTOV. Now we will test whether our installation works. I will not go into details on exactly what I'm doing here. That's for another video. If we open up the PTOV library, we'll notice there's a folder called tutorials, and inside of this there's a test installation. This provides a basic short synthetic track that we can test our installation up against. An important file in the PTOV library is this config.json. It basically configures the program to whatever settings we're trying to use now. In this case, I'm opening up the file located inside test installation. The first thing you will notice is there are lots of settings here. We don't need to change most of these, but the path we do need to set. So if we look under paths, there are 5 different things we need to set. The first is cal, which is short for calibration. To do this, I basically get the path to the calibration folder, which is this one, and I paste it in here. Then images is where the program loads the images from. To do this, I open up cam00, paste this in here, and open up cam01 and paste this in here. We have no background images in this case, as the images look like this, which is a simple silhouette image. Therefore, we do not enter anything in here. Next, we need to set the shapes, so where the program should look for the shape files. This, if we go into the PTOV library, we'll see that it comes with some shapes. Of course, you will not necessarily need these, but some others, so make sure you specify the correct path. I specify this here. Finally, I need to specify tracks. Tracks is what we call the output of the program, so that's the position and the orientation of the particle or particles that we are tracking. Here in the test installation file I have this tracks, which I'll use as an example. I've already run it, so there's a file here, but normally there won't be. Finally, something we can set is this opt images. This is the output path for where it saves the optimized images when it matches target and synthetic images. I'll go into the detail on this later. We've now set everything we need to set here, so we press save and then we close the config file. Now we need to run the program. To do this, I like to use Spider, so I pip install Spider. You can use whatever IDE you like. This is just my preference. And I open up Spider. Mine already opens this run.main, but let's assume that doesn't happen. Then we need to open the file. We go to desktop and PTOV, and here I save the run main.py. What we need to specify here is the path to the config files. Notice this is a list in case you want multiple, but in our case we just want one. So we find the path to the test installation under tutorials. We copy this, we insert it here. Finally, we need to run the program. To do this, we basically press run. Two things will happen now. First, a PTV is run, and then here starts the optimization of the images. What it basically displays here is the number of iterations and the cost that is achieved. This is to test the installation, so the track is short of only, you see here, 10 images. Now we want to verify that it works. To do this, I minimize Spider and I go to PTOV, Tutorials, Test Installation. It should now, under Tracks, have saved a new file. As you can see, it just saved it. Additionally, to check it, if we look under opt images, we'll see that it creates 10 images. These are the final position the optimizer gets to and each target image time step. If we open this up, we see here in the left column the target image, so the one we would have recorded in the laboratory, then the synthetic image, which is the one we're trying to match to the target image. Third column shows the residual image, so the absolute difference between the two. And in this plot we see the convergence of the optimization. Notice that it restarts multiple times before getting to a value it accepts, and then it does a long pass. If we scroll through these images, we see that the matches are very good. Can therefore confirm that our installation works well. Great, now we have installed the program. The next thing is of course to use this on some real data, and that will be for the next video.